Hi, I'm Dr. Mike, and I'm a medical doctor. After taking a break from YouTube, during which I moved into a new place and turned it into my cozy home, I'm back to show off my terrible accent to the world. Today we talk about lab-grown meat, what it is, how it is produced, and whether there are any dangers associated with consuming it. Are we all going to be eating meat out of a printer in a couple of years? The meat I've consumed over the years has changed. I can vividly remember when I first started getting into fitness at 19, trying to pack on some size by consuming as much protein as possible. Meat was the easiest and most obvious choice. My budget, however, was rather restricted. When faced with the choice between high-quality, organic, grass-fed, grass-finished beef, basically cows that had more room in their barn than I had in my student dorm, or that disgusting, brownish-looking minced meat, you know, the kind that's vacuum sealed so tightly it could double as a doorstep. I always opted for the budget-friendly meat priced at a measly $2 per half kilo, plus a couple of beers. As time passed, I saw a cow live for the first time and realized it isn't that purple animal Milka pretends it to be. I also saw piglets for the first time and decided I didn't want to support that kind of meat industry where the cows or pigs never see sunlight. I even tried eating vegetarian for 6 months, but that wasn't me. I'm digressing. Let's talk about grown meat. How is lab-grown meat made? We can't create meat out of thin air. The starting point is obtaining a muscle biopsy from the animal whose meat we want to replicate. The animal gets poked with a needle, not ideal, but it can be done pretty painlessly. Once we have the tissue, we can generate virtually endless amounts of meat. It's like that Brothers Grimm fairy tale, the magic porridge pot. A poor girl receives a magical pot that produces endless amounts of porridge when she says, "Cook, little pot, cook." One day, her mother forgets to say the stopping words and the pot overflows, filling the house and streets with porridge. Can you imagine the flies and rats all over the porridge? Disgusting. The next step is isolating the cells that form muscle tissue, the kind of meat that makes up steak. These cells need something to latch onto, a sort of frame, a scaffolding to keep them from turning into a shapeless blob. This structure mimics how muscle forms in an actual animal. After that, it's all about fooling these cells into thinking they are still inside the animal. The bioreactor, which serves as a womb for these cells, is like a 5-star resort. Perfect temperature, the right combination of nutrients, glucose, vitamins, minerals, oxygen, you name it. It's like the hyperbolic chamber in Dragon Ball Z, where Goku and Vegeta train to go big and strong. Now, you might be wondering, if the cells are in such perfect environment, how long does it take to grow a juicy steak practically out of thin air? Let's first look at how long it takes to raise animals for slaughter. It seems I am a baby eater. Ignoring the title, we can see that the fastest growing meat is chicken. Pigs take about 6 months and the cattle around 1 to 2.5 years. That's quite a long time in a day and age where more and more people found their appetite for meat. Longer-lived animals also consume more resources, which is why a steak is more expensive than a chicken breast. Lab-grown meat, however, takes just 3 to 5 weeks for a thin slice of meat to appear. This could revolutionize meat production, making it time-efficient, cruelty-free, and potentially more resource-efficient. What about the taste? Unfortunately, I haven't had the opportunity to try lab-grown meat. From what I've seen, the taste is reported to be very similar to conventional meat, as demonstrated in this video.
It tastes really good.
Apparently my vocabulary for describing food is limited to really good.
It's really good. This is really good. It's really good.
One big advantage of lab-grown meat is that it avoids antibiotics and growth hormones. In conventional meat production, animals are kept in tight quarters, leading to disease outbreaks and the frequent need of antibiotics. Stress from these conditions and the lack of sunlight raises cortisol levels, making the meat more acidic, less tasty, rubbery, and overall less colorful. In lab-grown meat, antibiotics and growth hormones are completely avoided. However, the process must be incredibly sterile, as the bioreactor has no immune system. Any contamination with bacteria or viruses can ruin entire batches. What are downsides and challenges of lab-grown meat? First, scalability. Right now, lab-grown meat is not a product for the masses. Bioreactors aren't efficient and there are no large-scale facilities. Experts estimate that it will take another 10 years to make lab-grown meat readily available in supermarkets. Second is the cost. While prices have gone down significantly from $1,000 per kilogram in 2022 to around $100 per kilogram today, it is still too expensive for most consumers. Third, consumer skepticism. This is the biggest challenge. Most people see it as an unnatural manipulation, more like a product from a sci-fi movie than real food. Plus, the long-term health consequences are still unknown. Fourth, there are also some environmental considerations to keep in mind. If lab-grown meat production scales up, it could use less water and farmland than traditional farming. However, its environmental impact depends on the energy source powering the bioreactors. If fossil fuels are used, CO2 emissions might remain high. On the other hand, renewable or nuclear energy could make it a more sustainable option. I remain very curious about the space personally. However, I would not be interested enough right now to try it. What about you? Let me know in the comments. Bye bye.